All right, you guys have you have 4 different ready to learn topics this week. The first one is dealing with set notation. For set notation, the first thing you want to do is sketch out a number line. So in this case, we have -4 is less than. So we know from previous courses that if it's less than, we want to open circle. And that's because it's not including the -4. And we're going to go all the way up here to -1, which is also an open circle because it's not including the -1 because of the less than sign. All right, so that means that y could be any of the values in between here. And there's lots of values in between, but we're just going to focus on the integers. Okay, so for the set notation, we would not write -4 because -4 is not included. We will write -3 and we will write -2. And that's what it's asking you for. Look at this example. -4 is less than or equal to z, which is less than -2. All right, first off, we've got to start with a closed circle because we are including the -4. For -2, we have an open circle because we're not including the -2. So here's our number line. So we want to see what values are going to be included in the set notation. All right, so really there's only one value there. Let me put that more in the middle between the two. All right, so we are going to include the -4 this time because it just wants, when you do set notation, it just wants integers. But we can't include the -2 because it's not less than or equal to sign there. All right, so what if we have 2 less than or equal to signs? That means we're going to have 2 filled in circles. And we're going to have to see what falls in between the 2. So in this case, the only integer that falls between is -3. But this example is a little bit different because we are including both endpoints. So the set notation will include 3 numbers. Set notation can include as many integers that fits between the range of the inequality. The second is solving an equation to find the value of an expression. These questions are actually pretty easy, but it's worded kind of funny, so I think that's why some of you are having trouble. The first thing you want to do is solve the equation for x. All right, so we know that x equals 2. Then we have this other expression that we want to use that value of x for. So the first one, when you're solving that equation, you're finding the value of x that needs to be used for this expression. So this is going to be your answer. Start by solving for y. Once you know y, plug it into the expression and then type in the answer that you get. Did you get 3? If so, you were correct. The third is union and intersection of finite sets. Again, once you understand what this is asking, it's pretty easy. So anytime you see intersection, sometimes you might see it as L intersection M, and union you might see as L union M. It's having you find a specific value. So for intersection, it's what repeats. For union, it's all possible values. If you notice that D repeats in both sets, Therefore, your intersection is going to be D. The union is going to include everyone. So A, B, D, E, and H. I like to think of it as the union makes everyone happy because everyone gets to go. The intersection makes some people sad because only the people that repeat in both groups get to go. Which set notation would best represent the intersection of E and D? Choose an answer on the right. Because intersection wants to know which ones match in both sets, we're going to write 1 and 2. Okay, 1 and 2 are the ones that match. What about the union? The union is going to include all the possible values. So I have a -2, I have a -1, we have 1, we have 2, we have 3, we have 4, 5, and 7. That's going to be my union. Notice that if the number repeats in both of them, you only count it once for the union. And the fourth is determining whether or not something is a solution to the equation. All right, in this problem, you're trying to figure out if the value of V will make the inequality true. So let's start with a +4. And we're just going to plug it in and see if it works. Okay, because this is a greater than or equal to sign, and we know that -33 does equal -33, this one is a solution. Let's try -4. Okay, -33 is not greater than 39. It's also not equal to. So this one is not a solution. How about 1? This one's a little tricky. Let's think about it on a number line. So here's 0, here's -6. -33 is going to be way down there. Okay, so the values that are closer to 0 are actually bigger. So this would actually be false. All right, the video is going to stop so you can try to test 8. Decide if 8 is going to be a solution or not, and then answer the question to the right. This one is actually true because -69 is smaller than 33 because it's further away from 0.